in charge of the clinical use case here and how IGVF data could empower genomic medicine. So anybody who is practicing genomic medicine will know that variants of uncertain significance are a huge problem. And what we have on the left here are the contents of ClinVar for missense variations. So these are variants that cause amino acid changes. And basically, if you download ClinVar on January 1st of every year, you'll and count the number of benign versus pathogenic or variants of uncertain significance in the database. What you'll see is that there's been this exponential growth of variants of uncertain significance in the database. And this is not just a blocker to diagnostics, right? So underneath this are people who are getting tested for hereditary cancer or cardiovascular diseases. But it also is a blocker to the future of precision medicine, right? So how can you develop gene therapies or antisense oligos or even small molecule drugs if you don't know what these variants are doing? So there's many types of evidence that can be combined to classify variants as benign or pathogenic. Many of these sources of evidence are hard to come by, but two of them, variant effect predictions that are generated in silico, and experimental measurements of variant effect or functional data can be generated in the lab and are therefore scalable, right? We can go in the lab and we can generate this data for any variant in the genome, which is again part of the IGVF project. But we wanted to figure out how to make this evidence, these two sources of evidence, more powerful, right? So these are great pieces of evidence, especially the variant effect predictions that can be made for any or already exist for any nucleotide change or amino acid change in the genome. But there are challenges to using them. And again, with the experiments, sometimes they don't exist for your gene of interest. And that is what the coding variant focus group at the IGVF is trying to solve, right? So one is the data gap, right? How can we generate experiments at scale for genes that don't have any data yet? The calibration bottleneck. So as I will explain in a second, functional data and variant effect predictions are not evidence for variant interpretation, right? There's a translational step in there that thus far, until we fixed it, wasn't scalable. And third, a lot of the data and evidence hasn't been really useful to clinicians, mainly because the data was not available in a way that they could assess it and use it. And so that is something we've also tackled. Okay, so in terms of the data gap, again, as Jesse and Karen pointed out, the IGVF consortium is busy generating tons of variant effect data for genes that are probably that are very important to genomic medicine. So many of the genes that you'll see here, BRCA2, PALB2, BARD1, these are all on hereditary breast and ovarian cancer testing panels. TSC2 is another tumor suppressor. And like ENCODE, we are generating this data in standardized way. So in the consortium, we've generated about 100,000 variant effect measurements for 62,000 variants over 10 genes. And this is just tranche one of our data sets. You can find data for some of these in preprints, but most importantly, what you can find is that the data standards, so telling you exactly the quality metrics to which we have generated this data, are available on the IGVF portal as well. Okay, so beyond the data that we generated, we curated another 200,000 variant effect scores for 30 more clinically relevant genes. This was done by Malvika, Abbey, and Pankuri in our group. And that together with the data we generated from IGVF is about 250,000 variants over 40 genes. And again, these genes represent many different categories of disease, so cancer risk, uh, cardiovascular risk, and metabolic diseases, plus lots of other rare disease genes. Again, details of how we did this curation and the data set itself are available on archive. But as I told you already, functional data does not equal functional evidence. And so, how do we take these variant effect measurements or variant effect predictions and turn them into evidence? That was also the second part of what we tackled through IGVF. The Radovoyets and Pedrover groups developed new methods to take variant effect scores. What we're looking at on the left are pathogenic and benign versus all scores for MSH2, right? So MSH2 is a gene that underlies Lynch syndrome. And you can see that this assay, whatever it was, really separates the pathogenic and benign variants very nicely. But what does a score of 2 mean, right? How is a clinical geneticist going to use that? And what we did was we developed a new method that turns that information into what we would call ACMG points, right? So these are points toward pathogenicity and points toward or a benign classification. And the way we've done this is it takes it's pretty much all automated so that there's no human decisions in here, and it's way more accurate than the previous methods for doing this. And we did the same thing for variant effect predictions. So you can see that the predictions for MSH2 function from a very popular predictor, very accurate predictor called Revel. And you can see that they're kind of all slammed against the right side of this plot. And the way that is currently that these this data is currently turned into evidence is here, and you can see that the points don't line up with how the pathogenic and benign variants actually um, are distributed for this gene, but we recalibrated them so that you have to have a very high score to get points for pathogenicity, which makes sense, and or many more variants also get benign evidence, right? Because that's now been spread across this distribution. And so these methods are not just more accurate, but many more variants are receiving evidence, which is really important for variant classification. Okay. And just to show you just how powerful this could be, we asked, really simple question. Could this experimental data and the variant and the predictive evidence, like now that we have evidence and not data, how good are they at reclassifying variants of uncertain significance if we just use them alone? And the first thing we wanted to see was how discordant they would be with ClinVar. So we would add the points from the experimental data and the points from the variant effect data, or from the variant effect predictions, and apply them to known pathogenic and benign variants in ClinVar. And what we found was some move back to uncertain significance because we're taking evidence away, but fewer than 1%, about 61 whole variants out of the 12,000 here, actually switch categories, right? So we have very low discordance rate. And then when we do apply these to the 16,000 variants of uncertain significance in this data set that are covered by this data set, 75% of these VUS move to more definitive categories, most of them going to benign, which is what we would expect. And then we also can do this for the variants, right? Because we make and measure every possible variant in these genes. We've got 92,000 variants that have never been seen in the population. They're not in NOMAD, they're not in ClinVar. So we're kind of introducing the concept of pre-classification, right? So when somebody walks into a clinic with a brand new variant, we have enough evidence here for 62,000 of them, or 62% of them to be enough evidence for them to be classified definitively as either a pathogenic or likely pathogenic or likely benign. So this is all great, but how do you find this information? This is the key. We've got multiple sources here. So functional data and functional evidence, right? So the data, as Jesse and Karen just pointed out, can be found in the IGVF portal, right? So this is raw data. If you wanted to see it, you can search it in the portal. And if you look at the raw release data sets, you can see my name or others, and you can search for all of this data. If you want more process data, that's in the catalog. So this is the IGVF catalog, and you can search by gene here. From this gene page, you get all of the identifiers that you would want to make sure that this is the gene you're looking for. And then you can find the variant effect scores, and you can find the variant effect predictors and the variant effect scores from the functional assay that was performed on this gene. Okay. This again, this is a work in progress. So this is excellent progress for where we're at now. I would our DAC is dealing with many data types of which this is just one. But the cool design principle that the IGVF catalog was built on was that you can build apps on top of the IGVF catalog and really link these two pieces of data together. So we have linked the IGVF catalog to an existing resource for coding variants, which is MaveDB. And then we also built the IGVF Coding Variant Explorer, which is linked. This is right on the very front page of the catalog. And we'll go into the IGVF Coding Variant Explorer in a second. You can also get to these from here, from this link right here at IGVF. And so, okay. So we'll look at that. And then again, this is where we're trying to get evidence to clinicians, not just data. And so we built this Explorer that will take you to what we call MaveMD, where we've loaded not only the information, not only the variant effect scores, but all of the information that a clinician might want to see to evaluate this evidence for whether they would want to use it for variant classification. So if you go to the IGVF page, which is igvf.mavedb.org, and you want to figure out, well, which genes do they have data for, you can click here into the data sets and you'll see them, right? So we've got some CDC tier 1 genes right here. And then you can click into that, or we also have what we're calling Predict MD, which will take you to genes for which we have those recalibrations of the variant effect predictions here. Okay. Okay, so we're searching for a gene, a data set, and looking for updated predictions and calibrations. Okay. So if you search, you can also search for a variant. What's really nice is we have not you can search with a, HTTPS string, but we also have a fuzzy search, which is actually us calling ClinGen. So that's so ClinGen allele IDs are kind of backed underneath it, so it's really nice. So you'll get your variant here. We searched for a variant in MSH2. You can get the actual ClinGen allele ID. You'll see scores from 3 different variant effect predictors. And what is important here is you actually get the evidence associated with that score for each of these 3 predictors for this. And then you can also see that there is functional data for this experimentally derived functional data for this gene, for this variant. And you can see it actually gives you the evidence right up front. And also what we're calling like a quick assay facts sheet. It kind of looks like a nutrition label on purpose. From there, you can get to the predictive evidence or the functional evidence, and you can dig further into these. So if you dig further into the variant effect predictions, it'll show you that calibration performance, right? It'll show you where this variant lies in the histogram of all scores. It will also, if you overlay the clinical view, it'll show you where all the pathogenic and benign variants are also to show you how your variant compares to those. And then it also shows you the different calibrations on the bottom and those results so that you can evaluate whether or not this calibration makes sense for this gene and this variant. The same for the functional data. You'll see this distribution of all of the scores. You'll see different categories of normal function versus loss of function. These are author defined in this view here. You can search for your variant. This is a different variant, and you can see that is here in this bin. And then you can overlay, again, the clinical variants, and you can see how benign and pathogenic variants overlay that distribution and where your variant is. Right. And then you get some really, this is where all the curation kind of comes in about the assay, right? So these might be things that somebody who is using the data might want to know without having to read the paper. Can this assay measure splicing? No, right? So that's an important thing to know. Um, and what the assay was, right? So this is MSH2, it's a mismatch repair gene, and so the molecular mechanism kind of makes sense here. Okay. So please, this is at igvf.maybeb.org. You can also go directly to MabeDB and kind of poke around at all of these things and tell us what you think. If anything is broken, we really want to know that. But we take our design features kind of come from our users. So we would really appreciate any feedback that you had. And then, of course, the IGVF catalog has a lot more besides coding variants. And tomorrow you'll hear from Andreas from the Eingrid's lab at Stanford tell you more about how non-coding variants and enhancers can link to genes. Okay. And again, all of this couldn't have been done without this amazing group, the coding variant focus group,